Consider the solid sphere of radius r and mass density rho of r given by rho naught into 1 minus small r squared upon capital R squared. Okay, r is in between 0 and capital R. The minimum density of a liquid in which it will float is rho naught by 3, rho naught by 5, 2 rho naught by 5, 2 rho naught by 3. Okay. Now, because you want the density to be minimum, okay, because you want the density to be minimum, we have to assume that the sphere sinks completely, well, rather is completely below the free surface. Okay, no portion of the sphere is above the liquid surface. Therefore, volume will be maximum and therefore density will be minimum, density of liquid. Okay, density of liquid will be minimum. Weight, we have to find weight and we have to equate this weight with a buoyant force. Okay, now what is buoyant force? Buoyant force is the density of the liquid, let's say rho, into volume 4 by 3 into pi capital R cubed into G. Now look, there is no need for integration here because it's the volume of the sphere that matters. So even if it is of varying density, its volume is going to be the same. Okay, 4 by 3 pi R. Now can we find weight? Yes, we can find weight. Okay, density is a variable, right? Density is variable. So suppose I consider, okay, suppose I consider a shell like this. Okay, suppose I consider a shell like this. This is our radius capital R. Okay, now suppose I consider a shell of inner radius R and of thickness dr. Okay, suppose I consider a shell of radius R and a thickness dr, then what will be the elementary volume? Elementary volume will be 4 pi R squared, the surface area into dr. Is it clear? Or shall I explain? Okay, so this is the elementary volume. Okay, this is the elementary volume. So from elementary volume, if I multiply it by density, I will get the elementary mass, right? So it will be rho of R into 4 pi R squared dr. So what will be the weight? Therefore, weight will be equal to G into integral of dm, okay, over R. So let's do it now. R changes from 0 to capital R. What is the formula? Rho naught 1 minus rho naught 1 minus R squared by capital R squared into 4 pi R squared dr. Okay. Let's take the constants outside. 4 pi rho naught G into integral 0 to capital R. This will be R squared, okay, and this will be R raised to 4 upon capital R squared dr. Okay, 4 pi rho naught G into R cube by 3, no need to worry because lower limit is 0, minus this will be R raised to 5 upon 5 So it will be what? 4 pi rho naught g r cubed into 1 upon 3 minus 1 upon 5. So that will be 2 by 15. Okay. So 8 by 15 pi rho naught g r cube, right? 8 by 15 pi rho naught g r cube, that should be equated to this part, right? That should be equated to this part. Let us see now if we get things getting cancelled. G goes, r cube goes, pi goes, and what do we want? We want rho in terms of rho naught, right? We want rho in terms of rho naught. So rho will be rho naught into 8 by 15 into 3 by 4. Two by 5 rho naught. 2 by 5 rho naught. Is there 2 by 5? Yes, that is option C. According to me, two critical points in this problem. First, well, most of you will guess it. If you are familiar with band force, that weight is equal to band force. And yeah, of course, actually there are three of them. First one is this actually. For minimum density, the volume of the sphere inside the liquid should be maximum. Second is this Archimedes principle, and third is finding the mass of the sphere. Okay, finding the mass of the sphere by considering that elementary, let's say, mass, okay, or elementary volume. Now, if you do not know how that 4 pi r squared dr comes, I said multiply the surface area by dr. Now that may make sense if dr is very small. With surface area into that. But if you are not convinced with that, here is another take on that. Look. How dv equal to 4 pi r squared dr? Look, v is equal to 4 pi by 3 r cube, you know that. So what will be dv by dr? Derivative of r cube is 3r squared, correct? 3 goes, and then we can use this approximation that elementary volume delta v is equal to 4 pi r squared dr, and in the limiting case we can say dv is equal to 4 pi r squared. Got it?
Yes, sir.
Okay.